I am the lead. I helped start the detection program at Atlassian 3 years ago. After a red team operation, my manager was like, hey, he was like, create me a detection program. He's like, he had a couple rules. He said, give me a naming convention and create detections so that this would never happen again. So we kind of took it a step further. I've given a couple talks before about some of the software tooling, automation that we've created to help us in this process. So I'm not going to talk too much about that. I'm actually going to pretty much like glaze over that. If you want to find out about that, you can go look at one of the other talks from like whatever that one is in Indianapolis. So this is me. My name's Christian Burrows. Cool. Acknowledgements. First, thank you to LastCon. Thank you to the organizers. This is one of the first conferences that I was a part of, and I was a volunteer. I was a volunteer coordinator at one point. So, yeah, man. So I know what it's like. Most people here are doing this just for free. They're doing it, to pass knowledge and share it around, and that's cool. So thanks, y'all. OWASP, for me, that was pretty important coming up in the industry like 10 years ago. Going to all the study groups, going to the meetups, going to the conferences, that really helped level me up, so thank you. Some of the first people to mentor me and introduce me to Splunk, which is actually probably why I'm here, talking about detections. I showed up at this video game company called Tryon Worlds, and they were owned by some APT. If y'all go and look up Win in TI more than a game, I showed up and they were like, all right, here's the deal, we're owned. And so then they were like, learn Splunk, and I was like, holy Nike's okay. So that was fun. So thanks to those guys. Atlassian, my boss, the program managers, and all the analysts, individual contributors, and automation engineers. So I've been able to take this from like concept and idea into an actual deliverable in a program, and a pretty mature program. And then I'm giving a special thanks to my boy Ashley Blackmore. He helped me he enabled me in a good way and helped bring many of these ideas into concepts and into deliverables. He's a really badass developer. Cool. So y'all can get to know me a little bit. I'm actually going to kind of hopefully get to know y'all a little. I'm kind of going for the picture thing here. This is my boy, Dr Schnitzel. His full name is Dr Schnitzel. He's got a Twitter account. That's right. Yeah. If you looked at that @ handle on the entry slide, that was actually his. The reason I named him Dr. Schnitzelbane is because I lived in Switzerland for a while. Schnitzel and pommes frites. That's hammered pork and French fries. You can see some hammered pork in him. I wanted to name him Dr. Evil and then get a matching miniature poodle and name him Mini-Me. But that's kind of a bad name for a dog, so he's Schnitzel. I like interior design. This is Jonathan Adler. I like traveling. As I said, I just did a little bit. I'm flying out to Florida today. It's the company I work for. I'm not a PS5 guy. I do love tequila. Got season tickets to the FC. That's matcha. Cool. All right. So is the agenda. I kind of like lean into the whole keep things a little bit vague at this point to keep y'all interested. So those like kind of titles might not mean a whole lot. But what we're going to talk about is some terminology, my overview of what detections are and some of the motifs with this methodology. We'll discuss structuring your detections. We're going to spend a decent amount of time on the structure/alerting and detection strategy. That term was coined, I think, by Palantir. So we'll kind of go into that because I do think that's one of the more valuable things about kind of detection engineering. How to apply that in your own environment. This is going to be one of the motifs as well that I talk about. I find it pretty important that like none of this is prescriptive. It's really important that you understand your environment, you understand how to apply this in your own. We're going to talk about some processes and rituals, things that help move and keep this machine going. And then I basically just like spewed some technologies. We can kind of have a discussion there if we want. And then we'll wrap it up. So what will help me is kind of get an understanding of who I'm talking to here so that when I go into details, I know what to say. Is anybody here an individual contributor? Like an analyst? Okay. Is anybody managing a SOC or something like that? Okay, cool. Great. Okay. Anybody else have a role that they want to yell out to help me understand who I'm looking at? Cool. If this is fine to interrupt me in this, just throw a hand up, and we can talk mid conversation or mid talk. I'm not going to be offended. So what we are going to talk about, these things. If I won't be offended if you were expecting to learn how to catch everything, or if I was going to show you some super secret like Splunk sauce, but I'm not. I can talk about Splunk all fucking day. Oh, excuse me. I can talk about Splunk all day, but this is not what we're going to talk about here. I won't be offended if you leave. Cool. Boom. All right. So this is the part where I ask you questions and you think. I find this really important. So at the beginning, I'll give you context. At the beginning, when we started looking at detections, we had kind of like a tribal version of creating detections, right? And so some person had made a table, and it had just some random stuff, and it had row, column, and it was like this stuff. And a lot of it was really just superfluous. It was extra, didn't really add any value. And it was like, why are we doing this? And this was like a really big barrier of entry to analysts creating more detections, because it was boring as hell and it didn't add any value and there was no reason to do it. So the first thing we started doing was stripping away everything, right? It was like, what actually matters to us? And so it's weird that I drew inspiration from HP Tipping Point, but I did. It was my first IDS to really work with. And one of the things that I liked about them is their alerts I thought were pretty succinct in the naming. And so that was kind of like one thing that I just thought of in the back of my head at all times. I was like, what is important? And so we stripped it down to like the smallest format we could. So for you, in your company, what data is important to the person responding to the alerts? A lot of times it's not the same person that creates the detection that responds to the alert. They need context. What format is the alert going to be fed into? A lot of people work with Splunk, there's Elasticsearch, but where do those results go into? So it comes out JSON, does it get formatted? Does it get fixed? Does it look nice? Does it look pretty? Does it look ugly? Is it a snort rule? Is it suricata? What does your detectable landscape and infrastructure look like? AWS, it's pretty common. Azure, GCP. You have web services. You have your own specific applications. Do you use Kubernetes? Do you have workstation endpoint telemetry? Do you have server endpoint telemetry? So what's important to you in your environment? Is source control important to you? So if you're going to create detections, do you care about knowing if it's been edited? Do you want to be able to revert? Do you want to have a change log of every single thing that's happened to a detection? Are the logs actually usable? Sometimes some parts of an organization will be saying, hey, we need detection coverage. We feel like y'all aren't looking at us. And it's like, you are not lookable. I can't look at you. Your logs are disgusting. They don't mean anything to me. I can't even find any auditable actions out of this. It's before you can even commit to saving, one arm of your company with detections, you have to be able to make sure that they can actually, that they have data for you to use. How do you want to communicate your results? Right? So not just your results of the alert, but how do you want to communicate your progress in your detection coverage? So if you know that you don't have any detections for AWS, how do you improve it? And then after you've improved it, how do you communicate the fact that you did improve it? How do you know that you're improving it? How can you measure your efficacy? Some of these things might not be important to you. And that's why this is really important to me. Because you can go and look at, Palantir, you can look at MITRE, and you can look at all these different frameworks, but They're not your environment. They built them for their own. Cool. So this is my general methodology overview. Select an adversarial technique. That part is pretty flexible. So I do like the MITRE attack framework as a starting point at the tactic level. For technique, it kind of depends on like your maturity level and your attack surface. You know, like what. I mean, do you have Windows? Are you in a Windows environment? So like a lot of MITRE techniques are tailored towards Windows environments. To be frank, most of the stuff that we create is tangentially related to some of these techniques, but they're not. It's not like a one-to-one matchup with a technique, right? So I start at the tactic level, right? So like defense evasion, lateral movement, privilege escalation, right? That kind of thing. So in general, when creating a detection, this is what our analysts do. They research it. Proof of concept is really nice. It's not always possible. Identify data sources. For a lot of people, this is index equals network kind of shit. Build the detection, right? Okay, so this part, I didn't put this drawing in, but I did a detection class with Spectre Ops. I guess that was 2 years ago. Man, it's so hard to tell. Pandemic really changed a lot of stuff. I think maybe that was right before the pandemic. It was like mid-January. Last ShmooCon I went to also. So what he talked about was kind of like the sort of like, I don't know what you'd call it. It's like the spectrum, the detection spectrum, right? So if you create a detection which is like, I'm going to detect Mimikatz, reading memory 000017. It's like extremely precise, right? But then if you like just create a more generic one, it's like kind of broad. And so you have, less like false negatives, you have more false positives, kind of thing. So understanding like where your detection lands on that spectrum is kind of nice. And I'll talk a little bit more about that in detail. This is just kind of the overview. Peer review, super important. One of the things that was kind of initially like concerning for some people on the team was that we would just kick out detections because that was a requirement that we decided to make. It's like, oh, we're just going to kick out like shit detections. In practice, that didn't happen because people take pride in their work. The peer review process is kind of difficult because things like Splunk searches are pretty subjective, and like unless you're going to go and rewrite the entire thing yourself, it's again just pretty subjective. So you can make improvements. You can make improvements to Splunk searches, but in general, it's like if I am an analyst responding to the results from an alert that I did not write, is there enough context? Is there enough data in the response? Are the results actionable for me to be able to respond to this with no prior knowledge of the detection? That's really the goal of the peer review. Yep.
What about stuff like validation pipelines or something analogous to unit tests in the software development lifecycle? Like, how do you do that? When you're kind of building things ad hoc?
Yeah. So the question was, what about validation in unit tests? So in theory, part of it comes from this. But when we were talking about actual like quality execution of the detection, is it running? I mean, that's a gigantic piece of the puzzle. You get the ability to do this when you start adhering to a standard or a framework. This is something I talked about a little bit in another talk. But in short, if you make every single detection have the exact same shape, then you're able to perform unit tests. If that makes sense. So if you have it in a structured object, I told you I want to talk about Jira, but we create a detection issue type, and we use the Jira API. We do our incident response in Jira. We track everything there. So if there's a detection, that is the initial detection thing. So this has, I'll talk about the ADS kind of strategy, has all that. That propagates to alerts. Those alerts can propagate to an incident. So then you have this kind of like chain of that. So when it comes to actually like executing those, for us, I mean, like I'm vendor agnostic. Like it's just, this is the technologies we use. It's the reality. We use Splunk. So we built a pretty big CI/CD pipeline to validate every single search at multiple levels. So we execute every single search in CI/CD to verify that it has no syntax failures. It's called like a B tool, I think is the Splunk command. And that'll actually just do a top level like configuration check on everything, and it'll emit any errors. We also wrote a little tool to execute the search itself, just to make sure that it runs. And then in addition to that, we do daily runs of every single detection using something that we call Splunk Doctor. And that looks for things like runtime, number of results that is searching through, are the fields still valid? So I mean, we've invested a lot of time into that. I highlight automation as pretty much one of the biggest reasons for our success with this. Does that answer your question a bit? Cool. Mm-hmm. Yep.
You started to allude to, and that's where how do you address the detection that does what it says and is meaningful to the analyst versus it doesn't crush your sale? I think that's where your Splunk Doctor comes in. Is that proprietary or is that something that
It started out as an idea that we didn't know how we could accomplish, and then we brought in an intern, and that's kind of one of the beauties of young developers. You give them the problems that everyone else says is impossible, and then they can do it. So I'm encouraging them this year to work on open sourcing it. God dang, open sourcing's hard when you're in a fast-paced like multi-billion-dollar company. Like it's hard to like stop and take time just to like open source something for everybody else. Even if it's good for you, if it's good for the community, it's just hard to take that time. Come back to that one. Cool. All right. So this is where I'm going to spend a bunch of time. Cool. So before I knew about this, before I'd heard the term ADS, we had developed our own ADS. So me and my boy Ashley, we got on a whiteboard for days on end, and we just whiteboarded forever, and we came up with our things that were important to us in a detection. Palantir talks about some of the things and reasons why they developed an ADS. And I'm going to highlight the things that are important here. Lack of rigor around the creation, suboptimal alerts going into production, no documentation, no peer review. Those are like categorically the same issues that we had, and the reason why we developed what we did. Right? You can go check that out. It's a really good starting point, and I'll even talk about it a little bit. So Palantir's ADS framework is made up of these sections. Okay, so if you are creating a detection, these are the areas and categories that you must fill out before this goes to peer review, before it goes into your production pipeline. So what part of the framework is important for you and your team? Are you short on resources? Is it more important that you move quickly than as comprehensively as this framework demands? Cool. So me, I'm a big believer in lightweight. I want to go like as light as possible. So that was why the very first thing that I did was just strip away every single thing I could. So if it were me, which it is, this is where I start. These are like kind of like the most important things. It's pretty amazing what a naming convention gets you. It's like just shockingly amazing. you have to remember that like you got to live with that. So you like, don't do something that you hate. You know, if you're spewing out hundreds of alerts a day, A, that's too many. But B, you gotta be okay with the name that you choose. What should the name be? I say that it's one of the biggest quality of life improvements. Naming things is hard, and most of the time, not everyone in the room will like the name that you pick, but it doesn't really matter that much. In general, you're not gonna make everyone happy. What you're aiming for, what I believe that you should try and do when you create your own naming convention is make it descriptive. I literally named our tool the standardizer. Like you could call it Mega Man, you could call it Superman. You know, there's like everyone wants to like have some really cool, catchy names. With this, for an analyst, I mean, I was responding to phishing email reports, you know, just 2 years ago. I understand very well the mindset of an analyst, right? When you get a deluge of data coming in, if you see something across your face, like your brain's already like, you know, a minute ahead. If you give yourself a name that's helpful to your brain, kickstarting that analysis and triage process, that's a win. So make your name descriptive. And again, yes, it matters, but it kind of you just got to pick something and do it. So for us, it's like we use like a primary key. We talk about the scope. We talk about the data source, the MITRE tactic, and then the short name. So I kind of stole like AWS's like double colons, and it's like primary key, scope, data source, short name. So I use a human readable name. I'll show you this later. Cool. I'll stick to the script. The documentation of the detection is very important. We have multiple views for different objectives. So talking about detection context. If I'm the detection author, I've created a detection. I have this like my creation view. Again, I told you all it's in Jira. That's just where we do it. We also take it and we emit it into Confluence onto like an executive kind of view. We emit it into JSON. It's a structured object straight out of Jira. So I can shove it like anywhere in any format that I want. The reason why this is important is because, again, you're not always responding to the same alert that you created, and people might not have any context. So part of that documentation should include context behind why the detection was created. The original author should explain motivation, general good or bad things about the detection, how they came to create the detection that they did. And we capture this all with, so the person that creates this, they'll like write comments, they'll be like, hey, I came into this problem. We have peer review, those comments are captured. So I can go back, I can look at detections that were created 2 years ago, see any improvements, maintenance, changes, conversations that have happened, the entire life cycle of that. I can look at every single alert that's ever fired for that same detection and look at like commonalities, right? The dream for me is that you automate and you create like a feedback loop between all those alerts, right? That they're kind of like aware of each other. That part's a little harder to get to and kind of requires a slightly more mature program, but the idea is like if you have 1,000 results for one single alert, it's fired over 2 years, and you have 1,000 different ones. It's like, what can you learn about that? And it's not necessarily like machine learning. It's not like data modeling exactly, but what can you learn about that alert results? What can you do to speed up and reduce the overhead on your analysts? How can you, prevent them from getting like alert fatigue as they triage the same thing over and over and over and over and over? Woo! All right. Classifying metadata. Classifying the scope of the detection. So when I say scope, what does that mean? It's like workstations, AWS, server. You get more or less granular. I think basically my general principle with this is start small like this. And as you get more stable, as you get more solid with this, and this becomes easy, and you build automation around it, and you build like enrichment around it, and you're able to like build some reporting, some forecasting, using like just kind of this like small set, then add something. You know, I just now, like just like 2 weeks ago, and I've been doing this for like 2 years, this just detection program, I just added sub capabilities to being able to understand how well we're doing at detecting cloud stuff, right? Whatever the hell cloud stuff means. And it's a really kind of hard problem. But basically we're in a good enough spot where we're stable enough that all of a sudden using the word cloud to talk about what it is we're trying to detect isn't necessarily good enough for us anymore, and we have the ability to get more granular. But we didn't start like that. So my recommendation, start small. If anybody read that one article, that one guy talks about the flywheel, I find that really powerful. I've made incremental improvements a part of my kind of mantra and work for a little while now. All right. Cool. So I talked to you all about the ADS that was provided by Palantir. I talked to you about some of the kind of like short-term things that I would do. And so now I'm going to show you exactly what I would do in a very mature program. So I wrote a methodology after doing this for like 2 years. I validated it with going to training, conferences, and kind of understanding where everybody else was at in the industry, where we were at. This is what I came up with. So if you saw Palantir's ADS, you'll see some similarities and some straight up that I've ripped. A couple of them we don't even use yet, but this is my theoretical ideal. I'll tell you which one I don't use, but other than that, this is all active in like our production detection program. Goal. So it's really important when you create a detection. What is detection logic aiming to detect? Like it might seem straightforward, but you'd be surprised how often you just forget to like stay focused. Scope. Categorization. I mean, the minor tactic. It's just pretty easy. Like you could try and roll your own, but there's not really any reason to. You know, it's like just use that. Let's see, human readable name. Cool. So I talked about this a little bit. So we do have a naming convention, right? But we have a human readable name too, right? Because we are humans still responding to this. This is pretty important. I cap this at 48 characters, just so that you can't like go on forever. We get some literary types in my field. Cool. Scope. You know, this is pretty important. So again, just for a reminder, refresher, what are we looking at? Why, like, what the hell are these? This is detection, right? The Splunk logic or your snort rule or whatever it is that you're doing, your query language, your Python, your behavioral analytics, that is a component of the detection, right? This is important to do at a holistic level. Otherwise, you're not going to scale. You're not going to be able to forecast where you're going. You're not going to be able to see where your blind spots are. You're not going to be able to see where you're doing good. You're not going to be able to see where you have detection coverage. You're not going to be able to report up. And your analysts, individual contributors, won't really understand the big picture of what they're doing. This is tedious. That's where you use automation to fill it up. Remember, this is a good starting point. This is comprehensive. Okay? So, scope. Detecting malicious activity in AWS, workstations, a product, right? You have your product, we have ours. And it's like, I can't tell you all of the products that you're going to have in scope. and they've got different types of logs. That's important. Data source, right? So for a lot of people, it's just index equals network, right? It's really just a way to, again, this helps understand for the person responding, what is this detection about? They might not have written this detection. They're responding to the alert. They need to know where it's coming from. Strategy abstract, Yeah, so some people are better at this than others. Like, I don't know, I think I'm kind of like a street computer guy. I'm probably not going to be the best at like your technical context. I'll be like, yeah, I'm like some hackers did some stupid stuff, and I think this is pretty bad, and this probably shouldn't ever happen. And then some people are going to write to like a dissertation. So this can be thought of as the research and development that went into learning about the underlying technology before and while the detection is developed. Capturing this content is helpful in bringing the overall knowledge of the team up by sharing technical knowledge and how the analyst got there. You have junior analysts, you have senior, you got whatever. If you show people how you came to the spot that you did, your whole team comes up. It's like no longer tribal knowledge. Blind spots. This is actually really good. The reason why I didn't like the idea of blind spots before because it just seemed like extra stuff that I had to do. But the reason why I like it now is because it helps you narrow the scope of your detection, right? You can't create a detection that detects everything. And admitting that is great, right? So what if you have a detection that looks for it like the same kind of thing, just 3 different ways? It's like, so what? Yeah, you do a little extra work, you have a little extra stuff going on, but like admit that you have blind spots, and that's fine. And then you're like, oh, okay, this detection is actually a lot easier to finish because I'm not trying to catch everything. I'm trying to catch this part, and I'm admitting like where this thing fails. So then you create a different one, which is better at detecting what this one doesn't, right? And that's okay. Yeah, false positives. I mean, come on, it's gonna happen. Putting these in is good. So you create a detection, right? And you run it back as far back as your data source allows. Here's your first Splunk trick. Bucket your search into like days or, bin span equals 4 hours, and then run it back 90 days. See how many times this thing would fire. And if you don't want to say like not quote windows.exe quote necessarily, right? So sometimes you just have to leave some false positives in there and document it. And then you can, if it's like consistent and you can like track it, then do some automation, post-processing later to make it easier on your analysts. Cool. Validation test. This one I think is really hard. And it takes a lot of effort from the individual contributor, from the author, to actually do a good job of this. In addition to that, this is kind of coming back to what you're talking about, you have to have infrastructure to be able to do this that feeds into your reporting pipeline the same way your production things that you're already trying to detect anyway are feeding up into, okay? So, as an example, I have a laptop. It's got CrowdStrike, it's got OS Query, it's got Silence, it's got everything on it, right? So I do something on it, and then like that feeds up into a AWS Kinesis stream, which goes into Splunk. If I write a detection and it's like, okay, repeat these bad steps, where do I do that? How do I mimic a workstation in a repeatable way? I mean, if it's Mac, you're talking about Mac OS licensing. That sucks, right? So it's hard. What this helps with is the comprehensive, kind of end-to-end authoring of the detection. It provides you a little more confidence that what you've created is real. It's not like fairy dust, right? So we tried we tried once, we tried twice to create like kind of a harness that we would mandate like Python or shell scripts for every single detection to be repeatable. That's not very scalable. It's pretty hard and requires a lot of edge casing. So there's another initiative to try it, which, keep experimenting. What we decided to invest more time on than that was the health of the searches. Make sure that they're running, make sure that the data source is still there, make sure the data source matches what the search thinks the data source is, right? Does the field arn.principal IP ID still exist in this data source? Because the search is looking for it, and without that field, the search is broken. So if your environment allows for it, if you can build a harness and a rig to do this, yeah, because otherwise, the one time you get owned, we're gonna be like, I thought we had a detection for that. And it's like, yeah, but that data source changed. F. That sucks. Priority severity. This one, again, I think this one is for when you're more mature. I don't think that one's that important early on. Cool. These are the last two in the alerting and detection strategy that we use. Response. This is really important. It's difficult because a lot of times this is like the last thing you do in the detection. And you might have spent 2 weeks developing this detection. You've done all this testing, you've set up a lab environment. You're like running Pacu against your whole AWS environment. And then it's like, okay, now let me get boring and tell the responder what to do. But it is so important. It's a real big bummer when you show up to the response steps and it's like, oh yeah, whatever. It's like not cool. But scheduling, how often this happens, right? So cool. So that was, that's kind of like, this is really the bread and butter of the things that have helped move us into a mature state. We talk about this as kind of like the core. Go watch the other talk on the standardizer to kind of like understand how this fits into automation and tooling. But doing this has really elevated us a lot, consistently mandating and enforcing all of this. Cool. So now I'm just going to talk about some more high-level stuff. Yeah. Get me. Yeah.
There's a lot of talk there around, eyes on glass and how people do this. How much of this is codified in like runbooks? And for each of those alerts that you're creating, how much of that is on paper or digital paper for the team to really learn from, or are they just constantly being updated? How much of a library is there for you guys?
Yeah. Every single one has a run book. Every single detection has a run book. Every single one has a run book. Does that answer your question?
Yeah, that's perfect.
Cool. All right. So how do you do this? So you have like an idea, right? Okay. I'm just going to tell y'all how we do it. We do detection cycles. We do this for a reason, because we have a pretty flat structure. A lot of y'all will not have a flat structure. But basically, we do it in 4-week chunks. So we say, for this 4 weeks, we're going to focus on the MITRE tactic, lateral movement, because we have been able to identify through all the categorization. And that's the effing beauty of this. Right? You start doing this at a structured level, you start scaling. Yeah, you start with one detection. That doesn't do much for you, but you have 100. 200, 300. And then all of a sudden you know where your weaker spots are, where you don't have detection coverage. You know, you can go into like a 3-dimensional matrix. So we determined we do not have detection coverage on AWS metadata endpoint, right? Or like AWS access and identity, right? So that's a bigger topic. So for 4 weeks, we focus on that. And then after knowing that, then we move to a different area, okay? So at the beginning, before the 4-week cycle begins, we get together and we talk about it. And sometimes we're like, this is where we forecasted, where we see that we're not doing good, and this is where we think we should be. Does anybody else have any ideas? And then we talk about potential areas where we could. And then break it down, let people talk. And it's a good way, especially right now in the kind of virtual working environment, to do this. So what areas are they most concerned about? Where can they write detections? Do you have Windows in your environment? Cool. So you brainstorm, you have a pretty good idea of like what you're gonna do. So then you actually kick off. I know it's like, look, I'm like I used to be the least process-oriented person. I was telling Doug, I used to not like Jira. There's something wrong with me. I like it now. But kick off. So you brainstorm, and then you move forward, and you say, all right, now we're going to start this week. John, what are you working on? Danny, what are you working on? Emily, what are you working on? Ayla, what are you working on? What are you gonna try? And everyone agrees, this is what we're gonna do. So then they start. And then we do a mid-cycle check-in. So what we found early was sometimes after 4 weeks, people would be like, I was struggling a lot, and I couldn't figure it out. It's like, oh man, we should have talked to you. Well, okay, so just like make it happen. So started doing the mid-cycle checkpoint. So what we do is we partner people up. We have them review each other's detections. We have them talk about like where they're struggling, and then they present to the broader audience. And they say, okay, this is what Danny was working on, and this is where they think they might have some struggles. And then you kind of like bring that tribal knowledge in, and people that might know something can help bring those forward or scrap it. You know, because like ideally you want a deliverable, right? Cool. All right. This was one of mine. This went pretty well. I started this with the idea of it being for incident response, as in we don't know about some product, we've never worked with it, but if it gets breached, we're on the lam. You know what I mean? So I put someone on it for 2 weeks, 3 weeks. They go talk to the team, they go talk to the developers, they go talk to the service owners, and they build out a breach readiness document, which includes like, if this product gets owned tomorrow, who do I contact? Who do I reach out to? Who's my first point of contact? Who's the best like engineer, developer that's gonna be able to answer all these questions? Because like, it's not like, it's, you know, it's kind of like the illusion of randomness. It's gonna happen, right? So diagrams, architecture, tribal knowledge. So you interview the developers. You ask the developers like skeletons in the closet or like your war game, like find out what it is that scares them. And then like literally document the log sources. You'd be surprised like how many log sources there are that nobody's ever looked at ever, that exist and that can help you or are totally worthless. And then what have you already done, or what have other teams already done? You have a product security team, you know, if you have an application security team, what have they done with this team that you don't know anything about? Maybe they have some embedded engineers. Maybe they emit some special log that is like, warning, this should never happen. You know, like seriously, like that, like it'd be a bummer if you found that out like way afterwards. So some of the benefits from this: mean time to resolution goes down. Clarity, you know, again, this is about helping the overhead on your analysts as they respond to stuff. It's going to cut time down. I've only got a little bit of time left, so I'm going to try and blow through this. This started out as incident response driven, but this is now, we use this for detections as well. So this gives us a whole lot of fuel to write detections for. Turns out understanding the architecture better, understanding the threats to and paths to privileged data, and knowing what the log sources are, these are also all good precursors to being able to write detections for something that you didn't know about. Cool. You might be able to see how I was feeling at the time that I wrote the tech reference. This is just like a random smattering of stuff. This is the stuff that just came top of mind. You can ask me about any of these later if you want. And boom. That's it. And it's 10:49. I think we have maybe time for any questions if anybody wants.
I have another question.
Yeah, what up?
Why have you guys evaluated using out of the box sim product? I mean, it sounds like you're using Splunk core and just you build your own pipelines and sim management workflows and all that stuff. Is there any, have you evaluated an out of the box solution to some of that? You can do it all in the same tool, like an enterprise security.
Yeah, right, like enterprise security.
Yeah.
Yeah. How do I defer this question? I think that it was kind of a constant debate between build versus buy, and to be honest, like sometimes you make the decision to build when you maybe could have made the decision to buy. I think the leadership basically has a lot of influence on that, their personal experiences with it in the past, how much they liked it, what they think you can actually get out of it. One of the I would say one of the most difficult things is procuring software and then demonstrating a lot of usage of it. Sometimes you procure something and then it sits in a closet for 6 months before anybody even touches it. It's kind of tough to answer. People have brought it up a few times about enterprise security. I guess that we just kind of took case management internal, and we decided to build because we had enough experience on Splunk.
Yeah,
I'm just trying to think it out loud with you. There's not like any like real easy answer to that. I mean, we talk. It's a constant discussion point. It's like maybe we should stop trying to build everything.
Well, I've talked to several people in your position who have built up all of their own, all of the incident management workflows and the integrations with the different, systems that some of the teams that you can get out of the box with some of these products, and they're happy with that.
Yeah.
They have more flexibility. So.
Yeah. We're starting to do that more right now. I think it's a matter of scaling. So
I'm looking at architects across the entire company,
mm-hmm.
And one of the challenges I have is creating a standard template for application logging, for operating system logging, for operational logging. Have you had to get down to that level and develop it and say, here's the standard, and we're following what the OWASP and this says to produce?
For
and
sure.
We've got security logs, we've got application logs, we've got performance logs, yada yada.
Yeah. The question was about app logging standards. On the agenda, I think at one point I had logging written down there, and then I was like, no, I'm not going to touch this. It's an arduous problem to overcome. I think it's in the similar boat as like the naming convention, in that you just make a decision and then that's it. You just stick to it. Like the SIM, like Splunk CIM, like that's the common information model. That's like a pretty good starting point. It covers like a decent amount. The hard part is like retroactively getting a bunch of developers to change code. And like, damn. Who are you to tell them how to do that? It's hard. I think it's a pretty big problem across the board. Sorry that I don't have a better answer for you. Yeah, basically we're going to dedicate an entire team to creating logging standards. You need like a lot of resources to do it, I think, effectively, you know. Bueno, está bien, muchas gracias. Thank you, everybody.